Dear student, this is the second class on the chapter special function, and in this chapter we will focus on the following topics. First, the gamma function, definition of gamma function. After that we will learn the properties of gamma function, and then value of gamma in terms of factorial, and then value of gamma half, and after that relation between gamma and beta functions, gamma functions as an infinite product, and finally some evaluation of some integrals. So this is the topics, these are the topics on which we will focus on today. And now go to the first topic, that is gamma function. The gamma function of an integer n is denoted by gamma n, and it is defined mathematically as gamma n is equal to 0 to infinity e to the power minus x and then x to the power n minus 1 dx. So this is, I am writing this as equation number 1, and which converges for values of n greater than 0. So if you if you wish to find out the value of gamma n for an integer n, then you should use this relation. And now we come to some properties of gamma functions. Now we wish to find out the value of gamma 1, and the gamma 1 has a value of 1. This can be put in the following way. First, we have to write the definition or write the expression for the gamma function of n that is given by gamma n is equal to in this expression. That is, gamma n is equal to, written here, gamma n is equal to 0 to infinity e to the power minus x, x to the power n minus 1 dx. Now just put n is equal to 1 in this expression. Then you will get gamma 1 that is equal to 0 to infinity e to the power x, and here x to the power will be 0, because in this case n is equal to 1. And this will give you integration 0 to infinity e to the power minus x dx. And if you integrate this, after integration, that will give you minus x, then e to the power minus x 0 to infinity. And if you use the limits, then for infinity, for this power for infinity, it will give you e to the power minus infinity, that is equal to 0, and then minus of then you use the this value minus of minus e to the power 0, that means 1. So from here gamma 1 is equal to 1, and this is very important relation, important property. And in calculation, in our future calculation in this lecture, we will frequently use gamma n is equal to 1. So this, and not only in this calculation, but also in case of some calculations in physics or engineering or mathematics, gamma 1 is very important. So gamma 1 is equal to 1. This property is one of the interesting property of gamma. Now come to another property which is called as reduction, recursion, or recurrence formula for gamma n. Okay. Now we start this this topic or this section from the definition of gamma function, that is gamma n is equal to 0 to infinity e to the minus x, then x to the power n minus 1 dx. Now just replace n by n plus 1. So then you will get from this expression that gamma n plus 1 will be equal to 0 to infinity e to the power minus x, then x to the power, you have replaced here n by n plus 1. So this will give you n plus 1 then minus 1. So it is equal to x to the power n and then dx. Now your job is to integrate this function, this integral by the method of integration by parts. And if you do that, then the left hand side is here, gamma n plus 1 is equal to, you keep this as x to the power n here, then integrate this function e to the power minus x, that will give you e to the power minus x 0 to infinity, then minus first differentiate this function, that is integration. Integration of this will differentiation of this function, that is x to the power n, will give you n x to the power n minus 1, and then the differentiation of x is 1, so it will give you n x to the power n minus 1 then into 1. So so I have not written here 1, so it's okay. And after that, the integration of this function that will give you minus e to the minus x and then dx, because you know that integration u dv is equal to u integration dv, then minus integration of dv by dx, then integration du, then dx, du. So you know that the formula, and this will give you null result, and from here this negative sign will convert, will give you positive sign, n into 0 to infinity e to the power minus x, this is written here, and then x to the n minus 1 dx. You know that this expression is nothing but gamma n, so that will finally give you n gamma n. That means from here you have understood, or you have learned another interesting property of gamma function that will be frequently used in due check calculation in our calculations, that is gamma n plus 1 is equal to n gamma n. Note that this is a very important property of gamma function, and this is very important relation which is known as the reduction formula for gamma, because in this case I will see here gamma is reduced by 1. So gamma n plus 1 is equal to n gamma 1 is another important property. Now, using this relation, that is equation, using equation 3, let's what can we do here? Now you know that gamma n plus 1 is equal to n gamma n. Now gamma n plus 1 can be rewritten as, see here, first n minus 1 then plus 1. So this will give you here, okay, this is gamma n plus 1, this will be gamma n, okay, it has written mistakenly gamma n plus 1, no, it is gamma n can be written as gamma n minus 1 then plus 1. So it is corrected here, gamma n minus 1 plus n, that is equal to gamma n. And you will know that from this relation that gamma n plus 1 is equal to n gamma n. So here n is replaced by n minus 1. So you can write it is equal to first n minus 1 then gamma n minus 1. So from here you can write gamma n is equal to n minus 1 gamma n minus 1. This is another important relation. Okay, so from here you learn that gamma n is equal to n minus 1 then gamma n minus 1. Okay, now another case is there. Also from equation 3 you know that gamma n plus 1, that is equation 3 is here. We have already obtained it. N gamma n plus 1 is equal to n gamma n, that is here. Again gamma n plus 1 is equal to n gamma n, and from here you can write gamma n, that is the right hand side, gamma n is equal to 1 by n gamma n plus 1. So from this relation, if you use n is equal to tends to 0 or n tends to 0 or n equals nearly equal to 0, then from this relation you can find out gamma n is infinity. So for n is equal to 0, gamma n is equal to infinity, that can be proved from this relation. Now come here to find out the values of gamma n in terms of factorial. This is the next topic, to find out the value of gamma n in terms of factorial. And you already are very familiar with this property of gamma function, that gamma n plus 1 is equal to n gamma n. So from here you can write gamma n plus 1, that is equal to gamma n plus 1 is equal to n gamma n is there. So you can write this function as gamma n as n minus 1 plus 1. So you can write gamma n plus 1 as is equal to first n gamma n, then this gamma n can be written as in this fashion. So gamma n plus 1 is equal to n into gamma n minus 1 plus n. Then you know that gamma n plus 1 is equal to n gamma n. So this n is taken here, and from this if you expand this, then you will get first n minus 1 is here, and then gamma n minus 1. And this n minus 1 gamma, first write these two terms here, okay, and this gamma n minus 1 can be written as a gamma n minus 2 plus n. And from here you can write these two terms is here, okay, and from here n minus 2 is there, and then gamma n minus 2. And in this way you can proceed further and can write n this expression is equal to n minus 1, then n minus 2, then n minus 3, gamma n minus 3. Then another, the next term will be n minus 3. After n minus 3, another term will come with these all terms, multiplying by n minus 4, then gamma n minus 4. Then another term will come with all these terms, that is n minus 5, then gamma n minus 5. And in this way, if you cross it, the last term will give you 1, gamma 1. Okay, 1 into gamma 1. This is the last term. And you know that gamma 1 is equal to 1. As I previously said that the gamma 1 will be frequently used in our next calculations. So gamma 1 is here, that has been proved earlier. So this gamma n plus 1 finally give you this result, that is n into n minus 1, then n minus 2, then n minus 3, and in this way it extends up to 1. So that this is completed up to 1, and you know that 1 into 2 into 3 into etc. into n minus 3, n minus 2, n minus 1 to up to n will give you factorial n. So gamma n plus 1 is nothing but factorial n. So from here you understand that or you calculated or you derive that gamma n plus, another form of gamma n plus 1 is equal to n factorial. This is equation 6, and this is also another important relation. And in this relation, if you write replace n by n minus 1 in this expression, then the left hand side will give you n, then n will replace, since n is replaced by n minus 1, so first write n minus 1, then plus 1 is there, that will give you n minus 1 factorial. So this is nothing but gamma n, and that will give you n minus 1 factorial. So another important relation arises or comes from here, that is gamma n is equal to n minus 1 factorial. So two important relations related to gamma function in terms of factorial are gamma n is equal to n minus 1 factorial and gamma n plus 1 is equal to n factorial. So the gamma function can be considered as a generalization of the factorial function to which it reduces when n is a positive integer. So we can easily transform a gamma function into its corresponding factorial using these relations. So now using these relations, that is first for relation 6, if you use n is equal to 0 in this relation, then that will give you gamma n, that is 0 plus 1, that is equal to 0 factor. That means gamma n is equal to 1, which is already been calculated. So if you, for negative value, gamma n becomes infinity, and the gamma function is also known as the, here you write it, just note this, the another name of the gamma function is Euler's integral of second kind. And now come to the next section, that is the value of gamma half. And in this section we will find out the value of gamma half. And the value of gamma half is very important in case of physics, engineering, as well as in mathematics. And in case of these subjects, gamma half is regularly used in different calculations. And in that respect, the value of gamma function is much more important, and it is therefore very much important to find out the value of gamma half. And here we are here to find out the value of gamma half. And you know that from the definition of gamma n, that gamma n can be written as 0 to infinity e to the power minus x, x to the power n minus 1 dx, which we learned in the very beginning of this lecture. So gamma n is equal to this, you know it, and you are very familiar with this expression. And here just you replace n by half. So here is that gamma half is equal to 0 to infinity e to the power minus x, and then you have replaced n by minus half. So x to the power minus half dx. And now here is the time to replace x by something else. Right here x is replaced by y square. So from here you can easily understand that y should be, that from this relation you can write 1 by root x, that is equal to 1 by y. And if you wish to change the limits of this integration, here is that here is x 0 and here y. When x is equal to 0, from this relation you can easily write y is equal to 0, and when x is equal to infinity, then from this relation you can better understand that y should be infinity. And from this relation also you can find out the value of dx, that is 2y dy. And now time to substitute these values, that is x and dx. Now from this relation, this expression gamma half is equal to 0 to infinity. Then since x is x is y square, so this will give you e to the power minus y square. Then x to the power minus half is there because you have taken as n is half in this case. So then n is half, since n is half, then half minus 1, that will give you x to the power minus half. So x to the power minus half means 1 by root x, that is equal to 1 by n, 1 by y, that has been written here. And then the value of dx, that is from here to y dy. After simplification, this will give you this y cancel out, and this will give you 2 into 0 to infinity to the minus y square dy. So this is also an important relation through which gamma half can be mathematically derived, and this is written here. So now if you consider another function, another variable x instead of y, then gamma half can also be written as gamma half is equal to 2 into 0 to infinity e to the minus x squared dx. Here one thing has done here, only the value of gamma half is found out here for another variable x. So nothing is very confusion. Nothing is confusion here. Nothing is confusion. Don't be confused, because this we have find out this as a relation for the variable y, and here is another variable x. Now if we multiply this expression with this expression, that will give you gamma half square. This is gamma half and this is gamma, that will give you gamma half square, that is equal to 2, and this 2 will give 4, and 0 to infinity is the limit, and here also the limit is 0 to infinity. So 0 to infinity e to the power minus of x square plus y square, it is okay, and then dx dy. And now interesting thing is to just replace this. This is in Cartesian coordinate. Now just you replace this in polar coordinate. So if you wish to transfer or convert this relation into polar coordinates, then you know that in polar coordinates x is written as r cos theta and y is written as r sin theta. Okay, and then also you know that d theta dx dy. So dx dy is equal to r d theta dr. You also know that, and you are very familiar with this conversion of coordinates from Cartesian to polar coordinates. So from here you know that in polar coordinates x is equal to r cos theta, y is equal to sin theta, and addition and with that dx dy will be r dr d theta. So just substitute these values in this expression. So gamma half whole square, that is equal to 4, and in that case r is the limit of r is from 0 to infinity, and theta is 0 to pi by 2. So 4 theta is equal to 0 to pi by 2, and then r is equal to 0 to infinity e to the minus r square r dr d theta. And that will give you first just integrate this d theta. So if you integrate this d theta, it will give you theta. And if you use the limit pi by 0 to pi by 2, then that will give you pi by 2. So 4 is there, and an integration of d theta will give you pi by 2, and then the rest for 0 to infinity e to the minus r square r dr. So from here 2 pi 0 to infinity e to the minus r square r dr. Now let r square is equal to z, and then if you differentiate this, it will give you r dr, that is equal to dz, or from here r dr is equal to half dz. So from here, from this expression, gamma half whole square is equal to 2 pi is there, okay, this 2 pi, then 0 to infinity. If you use the limits 0 to infinity for r, then also the limit of integration of z also will be 0 to infinity. So that is there, 0 to infinity e to the power, just substitute r square as z, that is equal to minus z, okay, e to the minus z, and then d r dr, here r dr is there, r dr is equal to half dz, so half dz, that will give you this to will cancel, and that will give you pi 0 to infinity to the minus z dz. And if you integrate these, that will give you pi is first here, and then minus e to the minus z 0 to infinity, and if you use the value of 0 and infinity in this expression, that will give you 1. So finally you obtained gamma half whole square, that is equal to pi, and from here gamma half is equal to root pi. This is equation number. So finally we get gamma half is equal to pi, and this value, or this expression, or this value of gamma half, that is equal to pi by 2, is also very important, and that will be used in our next calculations. And using this formula, gamma function of off-Hardy integrals can easily found out using this formula. Okay. For example, if you wish to find out the value of 3 by 2, 5 by 2, 7 by 2, that can be easily found out using this equation, or employing gamma half is equal to root pi. Because in case of even integers, there is no problem to find out, because even integrals can be written as say n can be written as n plus 1 minus n. So it is very easily, it's very can be find out very easily. But in case of odd half integrals, you have to use this relation. Let us we consider the following examples. First, let us we consider find out the value of gamma 3 by 2. And you know that gamma 3 by 2 can be written as gamma half plus 1. And you know that gamma n plus 1 is equal to n gamma n. That is equal to n is here half, and then gamma half. And that is equal to, you know, the value of gamma half. You have already calculated here. Gamma half is equal to root pi. So half and root pi. So root pi by 2. In the similar way, gamma 7 by 2 calculated. And here is the entire calculation is here given. You will just look at it, go through this, and finally you will get 5 by 4 root pi. And in this way you can find other odd half integrals of integrals. Now come to the next topic, that is gamma function for negative values of n. And it is rather important to find out the values of negative integrals, because we already know how to find out the values of positive integrals. That is, it may be even integer, or maybe odd integers. The method or the process how to find out the values for positive values of n is already has already understood. Now come to the point that for negative values of n, we wish to find out gamma function for negative values of n. And you know from the relation that gamma n plus n is equal to n gamma n. And from this relation, you have already known, or you are familiar with this expression, with this kind of expression, with this identity. And from here you can write gamma n is equal to 1 by n, gamma n plus 1. This is equation 9. Now we are here to find out the negative values of n. What will be the value of the gamma function of negative values? For example, it may be minus half. It is taken as minus half. Then using this relation, you can easily find out that value. And here you have used n equal to minus half. So from this relation, gamma minus half, that will give you 1 by n, that means 1 by minus half, and then gamma n plus 1, that means minus half plus 1. So that is done here. That is equal to, this will give you gamma half, and that is minus half. And that this is finally give you minus 2, and you know that gamma half is equal to root pi. So this is nothing but minus 2 root pi. After that, if you wish to find out the value of minus 3 by 2, then you have to apply this relation once again, and you have this minus gamma minus 3 by 2 can be written as here minus 3 by 2, and here minus 3 by 2 plus 1. That is nothing but this. And this will give you, here is minus 3 by 2, and you know that minus 3 by 2 plus 1. So you know this value actually give you minus half. And you are very familiar with the value of gamma minus half, that is minus 2 root pi. And use this value, you finally get 4 by 3 root pi. And in this way, you can find other values of negative values of gamma functions. And also from equation, you here once again from this equation, if you use any 0 from this equation, you can easily understand that gamma will be gamma 0 will be infinity from this relation. So for n is equal to 0, gamma n becomes infinity, and thereby also that is infinity. Okay. Now here is a problem. Here is the identity which you have to prove. That is show that gamma m is equal to gamma m plus n plus 1 by m into n plus 1 m into n plus 2. In this way, it extends up to n plus 1. You have to prove this identity or prove this relation. To prove this relation, we here also have to use a identity, that is gamma n plus 1 is equal to m gamma n. In this case, since you are to find out the value of gamma n, so gamma n plus 1 can be written as equal to m into gamma n. Okay, no problem is here. And in this way, gamma n plus 2, you can write gamma n plus 2 as gamma n plus 1 plus 1. Okay, and that is nothing but m plus 1 gamma n plus 1. And I hope there is no problem to understand it. And then furthermore, gamma n plus, right here, use the value of gamma n plus 1 in this expression. That will finally give you gamma n plus 2, that is equal to from here m gamma n. So m, then this value n plus 1, then gamma n, and so on. So you can write this term gamma n plus n plus 1. That is, this is an integer and plus 1. So that will give you n plus 1 first, then gamma n plus 1. And then just rewrite this expression as n plus n first, then gamma n plus n. You can write this n plus n as minus n, then plus n. So that will give you first n plus n is there, and then this can be written as, since you know that gamma n plus 1 is equal to n gamma n. So here n is n plus n minus 1. So that is written here, then gamma n plus n minus 1. And from here you also write that m plus n, then m plus n minus 1. Then from here m plus n minus 2, then gamma n plus n minus 2. So in this way, if you consider all the terms in this series, or all the values of gamma function, this gamma function, then that will give you gamma n plus n plus 1, that is the first term m plus n, then m plus n minus 1, then m plus n minus 2, then m plus n minus 3. In this way, it goes up to m plus n, m plus 2, then m plus 1, and finally it will give you m gamma n. Just proceed this, just continue these calculations, and the final term will be m, because the final term n is decreasing here, and at the finally this increase, this n is decreased in such a way that the final term of this term will give you 1. So finally you will get gamma n plus 1, and gamma n plus 1, you know that m gamma n. So this is the last. And that means you can write from here this expression that gamma m, that is equal to gamma m plus n divided by here m, then n plus 1, then n plus 2. In this way, m plus n. So this has been proved. Now another important job is or work or calculation we have to do here is to find out the relation between beta and gamma functions. So you know that the value of gamma function, the calculation of gamma function is rather in some cases rather important and rather complicated. And in that case, if you convert gamma function into the beta function into gamma function, and you know that the value of an integer of a gamma function is very simple, then if you once convert a gamma function, a beta function into gamma function, then the calculation will become very easy. So our intention will be to convert a gamma function, a beta function, convert a beta function to a gamma function as early as possible. And if we once do it, then we will enjoy the beauty of the calculation. So our intention or our wish or our motivation will be to convert a beta function to a gamma function as soon as possible within the calculation. And if it is done, then we will enjoy the calculation very much. And know that here also just recall the definition of gamma function, that is given by gamma m is equal to 0 to infinity e to the power minus t to the power m minus 1 dt. You know you can rewrite in this fashion, because here t is a variable. In the definition of this lecture, very beginning of the lecture, we use t as x. So no problem is there. This is the general form. So in generally, gamma m is written as root e to the power minus t to the power m minus 1 dt. Now just write t is equal to x square, and then dt will give you 2x dx. And see, from this relation the limit of integration will be unaltered. Okay, just look at this and just think of this conversion of limits. So and then we have from this relation gamma m is equal to gamma m is equal to first e to the power minus t that gives you e to the power minus x square, then t to the power m minus 1 means x square 2m minus 2, that is written here. So this term will give you e to the power x square, then x to the power 2m minus 2, and dt and the value of dt is here x dx with multiplication of 2 here. So 2 is go to infinity e to the power minus x square, and this x and will go to here as positive sign plus 1. So that will give you the power of x as 2m minus 1 dx. This is equation 10. And similarly, for another integer n, you can write the value of gamma n is equal to 2 0 to infinity to the power minus x square e to the 2n minus 1. Just following this relation. And since it is another integer, so the variable should be another one. So the variable in that case in this case is taken as 1. So this is equation number 1. And just now multiply these two equation, that is equation 10 and equation 11. And the left hand side will be gamma m, and the right side will be these two will 4, 0 to infinity, okay. E to the power, here is minus x square and here is y square minus y square, so that will give you minus x square plus y square, and then x to the power 2m minus 1, and then from here y to the power 2m minus 1 dx dy. So this is here the value of gamma n. Now let us consider we wish to convert this Cartesian expression, the value of the gamma from this expression, the value of gamma n, the product of gamma n and gamma n form. Here is Cartesian coordinate, and we wish to convert it from Cartesian to polar coordinate. And in that case, for if you convert Cartesian coordinate to a polar coordinate, that is in terms of r and theta, the relation between the variable x, that is x and r and theta are given as x is equal to r cos theta and y is equal to r sin theta, as well as dx dy is equal to r dr and d theta. D theta will be here, okay. In case of scanning of this page, theta has not come here. So it is here dx dy is equal to r dr d theta. And the limit of integration will be, as you known earlier, that theta is from 0 to pi by 2 and is from 0 to infinity. So then from equation 12, you can write the product of gamma n and gamma m is equal to 4 0 to infinity, then 0 to pi by 2 e to the power from here minus r square, okay, and then from here r to the power 2m minus 1 into cos theta to the power m minus 1. Just substitute here r cos theta instead of x, so that will give you this. And if you substitute r sin theta instead of y, that will give you r to the power 2n minus 1, then sin theta to the power 2n minus 1, and the value of dx dy is here r d theta dr, okay. That will give you 4 into 0 to infinity 0 to pi by 2 e to the power minus r square. And from here you see from here that here is r to the 2m minus 1, and here is another 2m minus 1, and here is r to the power 1. So finally the power of r will be 2 into m plus from here n and minus 1. Then cos theta to the power 2m minus 1 sin theta to the power 2n minus 1 d theta dr. So this can be written as just write this can be written as the product of two terms. These two terms are here. First is equal to pi by 2. Just separate these in terms of theta and r. So first term is 0 to pi by 2. The theta term is here. cos theta to the power 2m minus 1 sin theta to the power 2n minus 1 theta d theta. Just separate these two terms regarding theta and r. So that is first term is there. This is concerned with with theta, and here is term related to r, that is into 0 to infinity with multiplication of 2 e to the power minus r square, then r to the power 2 into m plus n minus 1 dr. And see that this is the another form. This is another form or alternative form of beta mn. You know that beta mn is equal to 0 to pi 2 into 0 to pi by 2 cos to the cos theta to the power 2m minus 1 sin theta to the power 2n minus 1 theta d theta is equal to beta mn. This is an alternative representation of beta mn. So the first term is beta mn, and the second term is here 0 to infinity e to the power minus r square e to the minus r square mn m plus n minus 1 dr. That is, if you just look at this, here 2 will be here. So if you look at this can be find that this is actually gamma m plus 1. So why it is gamma m plus 1? You have already calculated it. That is given in equation number 10. So go to equation number 10. Just go to equation number 10. This is equation number 10. Here gamma m is equal to 2 of 0 to infinity to minus x square x to the power 2m minus 1 dx. So just here replace x by r. So 2 0 to infinity to the minus r square, then x here 2 into m plus n minus 1. So just m is replaced by m plus n. So that is here. Here will be here there will be 2. So 2 0 to the minus r square m plus n minus 1 dr in accordance with equation number 10. That will give you gamma m plus n. So the product of gamma n will give you beta mn, the product of beta mn and gamma m plus n. So that is there. So from this relation you can find out the value of beta mn. So beta mn is equal to, from that relation, beta mn is equal to gamma m gamma n by gamma m plus n. This is rather important relation, and so very easily you can convert beta function to gamma function using this relation, using this expression, and that is why this expression is very important. So this is the required relation between beta and gamma functions. The above relation is extremely important for evaluating many definite integral given by gamma functions, or find their value is computed in terms of gamma functions, and in those cases the calculation becomes much more easier compared to if we use beta functions. So here are some examples. If you wish to find out the value of integration 0 to pi by 2 sin to the power 2x cos x to the power 2 dx. So here we are interested to find out the value of this integral. So just let I is equal to, consider I is equal to 0 to pi by 2 sin x to the power p cos x to the power 2x dx. Now this can be written as half, then 0 to pi by 2 is here, okay, and then 2 sin x to the power p 6 to the power 2 dx. And just rewrite this as, you can write this as half is here, this half, and then this can be written as 2 sin half p plus 1, okay, minus 1. So the here is, see here, this can be written as this term, here is this term 2 into sin to the px cos x to the q dx. That can be written here as in this way, that 2 0 to pi by 2 sin p plus 1 then minus 1 x and cos x to the power q plus 1 then minus 1 dx. And you know the general formula for beta mn in terms of cos theta and sin theta is 2 into 0 to pi by 2 sin 2n minus 1 x and then cos 2n minus 1 then x dx. So comparing that we find out from here that m is equal to p plus 1. So from here m is equal to p plus 1 by 2, and from here also n is equal to p plus 1 by 2. That is done here. So this is nothing but half beta p plus 1 by 2, and then q plus 1 by 2. So since an important we have already find out. So finally we get this. So the value of finally we get the value of I is equal to the integration is equal to beta half p plus 1 then half q plus 1. And we also know that beta m is equal to gamma n by gamma n plus n. Just use here the values of this is m and this is n, the value of this. So beta half p plus 1 and beta p plus 1 by 2, that will give you gamma p plus 1 by 2, then gamma q plus 1 by 2 by p plus 1 by 2 plus q plus 1 by 2, that is gamma p plus 1 by 2 gamma p plus 1 by 2 by gamma p plus q by 2 plus 1. This is the final result. Now here the uh, the the next topic is gamma function as an infinite product. So gamma function can be written as the product of as an infinite product, that is given here and that is done here, and you know that the gamma function is defined by it is very that was given in the beginning of this lecture, that gamma n is equal to 0 to infinity e to the power minus x to the power n minus 1 dx, and this expression or this function is considered true for or in this definition we have considered that n greater than 0, because in this case n greater at n is equal to 0 the integral diverges. So you should consider that n should be greater than 0 and that will remember for the rest part. Another more important fundamental definition of gamma function that was given by Euler. Euler has given another definition of a function that is given here, that is gamma m is equal to limit n tends to infinity 1 to 3 in this way n minus 1 by m into m plus 1 in this way m plus n minus 1 x to n to the power m. This is equation 15. This is the definition of gamma function of an integer m given by Euler. This is here, and which is defined in the entire complex, and this can be defined in entire complex plane except when m is equal to 0 or negative values, etc. And for where beta m becomes infinity. So according to this equation we can write, just remember this expression has given by Euler, and using this relation, just use the relation, just to replace m by 1, m plus 1, that is m is increased by 1. So gamma n plus 1 will give you limit n tends to infinity, then 1, 2, 3 in this way n minus 1, and just here replace m by m plus 1. So this will give you m plus 1 and this term will give you m plus 2, and in this way from here you will get m plus 1 then plus n minus 1, that is finally give you m plus 1, and then n to the power m plus 1, that is done here. And now the job is to simplify this equation. So that is, this is limit n tends to infinity, and I write here m into n. I have taken 1 n from here, so the rest will be n to the power m. So 1 n comes here, so here is n, and then this n plus n is here, and you have additionally taken m in this case. So this m, so in the denominator there will be m. So there is nothing, no problem is here. This m will cancel, and from this term 1n is taken here. So this is okay. So we can write this expression as m into n by m plus n, then into this series 1, 2, 3 to n minus 1, and here m into n plus 1, rest parts, and in this way m plus n minus 1. That is the term before that this term. This term is just before this term. Okay, and then n to the power n. And from here just simplify this n, and from here you can write this as this term. As if you take m n as a common terms, this will give you n into 1 plus n by n. This n will cancel, and these are the rest term of this expression, and that will give you, so gamma n plus 1 is equal to limit n tends to infinity. From here m by 1 plus n by n, then you know that this is nothing but your gamma function, because from this relation just employ this relation from equation number 15. The second part of this expression is nothing but gamma m. So finally you get gamma m plus 1 is equal to limit n tends to infinity m by 1 plus n by n gamma m, and that is equal to you also know that gamma m plus n is equal to m gamma m. So m gamma m plus 1 is equal to limit n tends to infinity m by 1 plus n by n gamma m, that is equal to m gamma m. So now just from these two relations, this and this, just so you can write that gamma m plus n, that is equal to m gamma n, that is written here, this term is written here, and this term is written here, that is limited to infinity m by 1 plus n by n gamma n. So this is another important relation. And here if you use the value of m is equal to 1 in equation number 15, that is in this equation, if you use m is equal to 1, okay, just use m is equal to 1 in equation number 15, that is in this equation. So gamma m, that is give you n tends to infinity 1 2 3 this way, n minus 1, and then here you use m is equal to 1, so 1 into this will give you 2, and then 3 in this way. This term will give you 1 will cancel out, and finally it will give you n. So that is here, n tends to infinity 1 2 3 in this way, n minus 1, and then 1 2 3 in this way n, and here there was a term n to the power n. So since n is 1, so this is n. So look at the this series starts from 1 and ends at n, and this series also starts at 1 and ends at n. So this is nothing but n factorial, and this is also nothing but n factorial, that will give you 1. So gamma n is equal to 1, which has been derived from the definition of gamma function by Euler. So that is consistent with the value of gamma 1 that was derived earlier. So this is seems to be correct. Okay. So gamma function, another definition of gamma function given by Euler is this. So now come to evaluate some integrals. Here first problem is here, and you have to find out the value of the integral 0 to 1 dx by 1 minus x to the power n. To solve this problem, to find out the value of this integral, we have to replace x to the power n by sin square theta. So from here you can write x is equal to sin theta to the power 2 by, and then dx is equal to differentiate this 2 by n will come first, then sin to the 2n minus 1, 2 by n minus 1 theta, then in differentiation of cos theta is sin theta will give you cos theta, this is that. So dx is equal to 2 by n sin 2 minus n by n, or you can write it as, or left it as sin 2 by n minus 1 theta cos theta d theta. And from here 1 minus x to the power n is equal to 1 minus cos square theta sin square theta, that will give you cos theta. So just look at this relation and if you use the value of 0, theta is equal to 0, then x will be 0, that is here. And if you use x is equal to 1, then theta will be pi by 2. So limits of integration for theta are 0 and pi by 2. So write just I is equal to 2 by n is here, first 0 to 1, the limit will be transferred to 0 to pi by 2. Then first write the value of dx is 2 by n sin theta to the power 2 minus n by n, or 2 by n minus 1. Then this cos theta is there, d theta, and the value of root over 1 minus x to the power n is cos theta. So this cos theta will cancel each other, and I will give you 2 by n 0 to pi by 2 sin theta to the power 2n minus 1 d theta. And this is, you know, and this is actually this term. Here I have written the final term, but this term come to here to find out the value of this term. From it now equation number 18 come here. Here is written this term 0 2 into 0 to pi by 2 sin to the power. We know that just recall the relation of beta mn, the alternative definition of beta mn, that is 2 into 0 to pi by 2 sin to the 2n minus 1 theta cos theta to the 2n minus 1 d theta. And you know that beta mn was given in terms of gamma function as gamma n by gamma m plus n. And now just if you write r is equal to half, n is equal to half, and m is equal to 1 by n. Just in this relation, you just write n is equal to 1 by n and n is equal to half. Then what you will see, or what you will get here is 2 by n is there from this relation. 2 by n is there, 0 to pi by 2, and you can write this as 2 into 1 by n minus 1 theta, and then cos. Since there is no cos term, so that is it is multiplied by 1, and that can be written as cos 2 into half minus 1 theta d theta. So this expression and this expression are the same, so that will give you 2 by n 0 to pi by 2 sine 2 by 2n minus n theta cos 2 by 0 theta, that is this term. So this is actually beta n half. Okay, this is actually beta n and half. So writing the value of this 2 into 0 to pi by 2 sine to the 2 by n minus 1 theta d theta is equal to actually beta 1 by n half. So using this relation, you will get I is equal to 1 by n beta. Here is that 1 by n beta n into half. Okay, n into half. And you know that beta m n is equal to beta m gamma n and then gamma n plus n. So just write this. So gamma 1 by n, then gamma half, and this n is there, n plus half. This value is given here, written here. So finally we get the value of the integration I is equal to 0 to 1 dx root over 1 minus x square n is equal to gamma half gamma 1 by n by gamma by n into gamma n plus half. So this has been done, and now the next problem is to find out the value of this integration, that is 0 to infinity to 1 x square dx. Just here, substitute x square, this x square as t square. So from here, x is written as, can be written as t by root a, and from here dx is equal to 1 by root a dt. And in this relation, just use the limit of x. If x is taken as 0, then t will be 0, and if x is infinity, then t will be infinity. So just substitute now. I is equal to, the limit will be transferred to the infinity, will be remain the same. Then just substitute the value of these terms. So e to the 1 is ax square will give you t square. Then dx will give you 1 by root a dt. That is equal to 1 by root a 0 to infinity to 1 is t square dt. So you know that gamma half is equal to 2 into 0 to infinity to 1 is t square dt. You are very familiar with this. You have already done it. So no problem is here. So I is equal to 1 by root a is there, and then this term will give you gamma half, and you know the value of gamma half is equal to root pi. So that will give you root pi by this 2 is there, and root a is there. So finally it will give you half root pi by a. Now another function is, another integral is given here, is equal to pi by 2 sine theta cube cos theta to the power 4 d theta. And this relation can be written in this way, half 2 into 0 to pi by 2 sine 2 into 2 minus 1, that is nothing but sine cube. Okay, 3 will be given as power, and then cos theta to the power 2 into 5 by 2 minus 1. That can be written in this way, because this will actually give you this 4, and this will give you this 3. And now compare this relation with alternative definition of gamma function, that is gamma mn is equal to 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta. And from here, if you compare these two, you easily can understand that n is equal to 2 and n is equal to pi by 2. So this is I will be according to equation 19, I is equal to this half is here, and beta 2 and pi by 2. And you know that beta mn is equal to gamma n by gamma m plus n. So that is here, half is here, this half is here, then gamma 2 and then gamma pi by 2, and here gamma 2 plus pi by 2. And that is, you know that this half is here, and you know that can be written as 2 as, or you know that factorial gamma n is equal to n minus 1 factorial. So this will give you 2 minus 1 factorial, and then 5 by 2 can be written as 3 by 2 plus 1, and here is this will give you actually 9 by 2, and this 9 by 2 can be written as 1 plus 7 by 2. That is equal to, from here half is here, half is half will be here, and then from here there will be 1, and from here 3 by 2 will be here, and gamma, because you know that gamma n plus 1 is equal to gamma n gamma n. So n plus 1 is equal to gamma n gamma n. So n gamma n. So 3 by 2 gamma 3 by 2, and here is 7 by 2 gamma 7 by 2. So and then will be another additional. This is how will be here. Okay, just here missing is here, this half is missing here. There you are just but in the next line it has not been missed here. So just there will be another half, and when you complete the whole calculation that is given here, you will get 2 by 35. So I0 is equal to y by 2 sin theta q cos theta to the 4 d theta is equal to 2 by 35. This is. Now here are another some problems which we wish to calculate, and these are given here, and now here are the solutions. First one is equal to 1 dx minus x to the 4, that is equal to 1. This is similar to that of this integral. Okay, the first, in this case the first integral is similar to this. So here the form is the similar. So form is the similar, dx 1 minus x to the power root over 1, so n was there. So in this case you just substitute x square is equal to sin theta, and if you once do it, the next can be written sin to the half theta, and from here dx is equal to half sin to the minus, or will be there theta d theta, and then cos theta. So dx is equal to half sin to the minus half theta cos theta d theta, and this is the change of the limits. Just look at this. Okay, just here put the value of x and find out the value of theta. That will give you that is given in this table. So, and here also 1 minus x to the 4 is equal to 1 over 1 minus sin square theta, that is that will give you cos theta. And now here just substitute the value of the x and this value. Here is substituted this, and that will give you and this relation can be written as 2 by 4, and this. As I have already did similar kind of calculations in the earlier calculation, so I am not going to the details, but detailed calculations are given here. And then we know that the definition of beta function as this. And now if you compare this relation and this relation, you will easily find out that m is equal to 1 by 4 and n is equal to 1. Just look at this. Just practice it. You can easily readily found out this. You can find this. Okay, then I is equal to, from here 1 by 2, 1 by 4, beta 1 by 4 half, and you know that beta mn is equal to this, and just simplify this, and this will give you finally I is equal to 4 pi gamma 1 4 gamma 3 4. Here is the entire calculation. Just look at this. I have left it for you. Just go through all these steps. Now the next one is I0 0 to pi by 2 root over tan theta d theta, and that can be written as 0 to pi by 2 sin theta by cos theta to the power half d theta. So I is further can be written as half 2 into 0 to pi by 2 sin to the half theta cos to the minus half theta d theta. And here if you compare this with the already definition of beta function, that is beta mn is equal to 2 into 0 to pi by 2 sin theta to the power 2m minus 1 cos theta to the power 2n minus 1, then d theta, and then you will find you can find out that n is equal to 4 1 4 and m is equal to 3 by 4. This is done here. Just calculate. There is nothing very difficult to understand. Just look at this. Okay, then we get m is equal to 3 by 2, n is equal to 1 4. So I will give you half beta 3 by 4 1 4. Just here is the simplification. Simplify here, only just simplification here, only In this case, the property is employed here is that gamma mn is equal to gamma m into gamma n by gamma n plus n. Just calculate it. So finally, you will get and also the property gamma 1 is equal to 1. This is also used here. So finally, you get 0 to pi by 2 over tan theta theta is equal to half gamma 3 by 4 gamma 1 4. So just do it. This is just practice it. Okay, now the third one is 0 to 1 x to the 4 natural log 1 by x whole cube dx. And in this substitute x is going to be given as t by 5. It given as t by 5. So dx will be this t is not here. Okay, this not is not here. That was in another page or in the time of scanning. It appears here. So these two things are not here. Okay. So if you differentiate it, that will give you dx is equal to minus 1 by 5 from here, then it will go minus t by 5, then dt. And from this relation, 1 by x will be e to the power 1 by x will be e to the t by 5. And if you take logarithm on both sides, that will give you log 1 by x is equal to t by 5. And here is the conversion of limits. You can easily understand from this relation. That is when x is equal to 0, t is infinity, and when x is equal to 1, t is equal to 0. So here from here I is equal to just infinity to 0, because 0 at 0 it is infinity, so infinity is 0, and then x to the power 4, x to the 4 is here, to the power minus 4t by 5, and then the value of this term log x log 1 by x to the power 3, log x is here, t by 5, so t by 5 whole cube, that means t2 by 125, and then the tx, that means minus 1 by 5, then it will be minus t by 5 is here, t by minus t by 5 is there, and dt. So from here it is equal to, it can be written as the limit, since it is negative sign, so and the limit has been changed here, so 0 to infinity 1 by 6 to 5, then it will be minus t cube dt. Just simplify this. This is another equation, and from the definition of Gauss function, you know that gamma n is equal to 0 to infinity to the minus t x to the n minus 1 dt. Just compare these two. You can find easily from here that n is 2 in this case. So n is it is 3. So n is 4 in this case. So that will give you I is equal to 1 by 6 to 5 comma. From this it will give you gamma 4. It is 1 by 6 to 5. It is written as gamma 3 plus 1. And 3 plus 1 will give you, since you know that gamma n plus 1 is equal to n gamma n. So 3 by 6 to 5 comma 2 plus 1, in this way finally you get 6 by 6 to 5. Okay, since gamma 1 is equal to 1. So the value of this integration is 6 by 6 to 5. And here are some evaluation of some function of integers, 5 by 2 here, minus 5 by 2 here, 2 by 5 and 5 by 2. So just it has, I am leaving this for your practice. Just only use these, and these values will not give you difficulty. You will not suffer any difficulty to find out these values for positive integers. So only you use the relation that gamma n plus 1 is equal to n gamma n. That should be employed for both these and these. That are done in this case here. Okay, just go through this. And in the case of negative integers, you know that gamma n plus 1, that is equal to n gamma n. And from here, gamma n is equal to gamma n plus 1 by n. Just employ this relation to find out the value of negative integers. So here is the first calculation. Just I am stopping here for the up while, and then for the negative integer minus 5 by 2, that is here, and for the next one, that is here. Just follow these calculations, and it is very easy, not very difficult. Just you have to practice, and just you have to do it your own with following these steps. There will be no problem to understand. And here is another one. Here is another two problems. You have to prove or show that beta x plus 1 y, that is equal to x y x plus 1 beta xy, and beta x y plus 1 is equal to y by x plus y beta xy. And to prove these relations, you have to employ or recall the relation between gamma and beta function that is written here, that is given here. Beta xy is equal to gamma x y by gamma x plus y. And then if you replace x plus 1 in this relation, then that will give you beta x plus 1 y, that is equal to gamma x plus 1 gamma y by gamma x plus y plus 1. So from the above relation, you know that here is the as an identity gamma n plus 1 is equal to n gamma n. So here is n is x. So this can be written as x into gamma x, then gamma y, and this can be written as x plus y gamma x plus y using this identity. So finally, beta x plus 1 y is equal to, you also know that this gamma x gamma y by gamma x plus y is nothing but beta xy. So from here x by x plus y beta xy. So it has been proved. And further, beta x into y plus 1, that is in this relation. In this relation, we have just replaced y by y plus 1. So that will give you gamma x, then gamma y plus 1, and then gamma x plus y plus 1. And after that, just following these steps, we can finally find out that beta x y plus 1 is equal to y beta xy. So this is also proved here, and this is the end of this lecture. And you are required to go through this lecture and practice the calculations and drive all the calculations in your own, and obviously following this what is done here, and then everything will be very, very clear to you. And I think there will be no problem to understand all the things that is dealt in this lecture.